Okay, hey girls. As promised, I have video notes for today. I'm not sure whether it's a digital day or I'm just absent, but here we go. So what we're going to do today, what I'm going to go over in this video is, first of all, I want you guys to check your homework. The homework is in your OneNote as 1.20.22 homework answers. So check your homework from last class. If you have any questions about it, ask a neighbor or ask someone in the class who you trust or feels like you understood it, but see if you can get some help from a classmate, and if not, I will help you on Monday when I get back. What we are going to do is keep going here. We're going to do video notes 5.2, so we're going to go over relative extrema, which actually uses all of our increasing and decreasing functions that we found. So we're going to use those processes to find relative extrema. And then your homework will be this homework 5.2.1 relative extrema page in OneNote. All right, so I know you should, so here's your homework answers. So again, hopefully you guys can go through those. If this is a digital day and there's nowhere you can find help, obviously we'll go over those again in class on Monday. But let's go ahead and get to the notes for today. So what we're looking at today is we're looking at using the ability to find increasing and decreasing intervals of a function. We're going to use those to now find what we call relative extrema of a function. And by relative extrema, we mean relative maximums and relative minimums. When we say the word relative, again, what I'm referring to is in relation to all the points around it, what would be a relative max or a relative min. For example, if we look at this little graph here, we can see x of 1 is the highest point of most of the points around it, right? So if we thought about like just taking the interval that I've drawn here, like just taking this interval from here to here, then this point right here would be a maximum relative to the points immediately in that interval, right? It may not be the highest point of the whole function, but relative to the points around it, it's a max. Same thing when we look at this point right here, right? If we call this point x of 3, then relative to the points immediately around it, it is a high point, a maximum. So it would be a relative max. If we look at x of 2, again, if we took just the points around it, like, so let's say this interval, then this would be a low point just if we're just concentrating on this interval, right? Then this would be a relative minimum point. Again, it's not the lowest point of the whole function, but relative to the close points, it's a minimum. Same thing here for x of 4. If we just looked at the interval around it, relative points to it, it's a min, okay? So that's what relative min and max look like on a graph. If we look at the calculus rules, we can find actually the calculus definition of a relative min. So again, this is kind of a confusing way to think about it, but this is how your textbook talks about it. So we're going to use that language for now. So this just says for a function f defined over any open interval, and they're calling the interval endpoints a and b, and they're saying, let's say this interval contains a point c. So they're using c as really any point in the interval, okay? So then the rule states that if f of x, sorry about that, okay? They're saying if f of x, which again is another word for y values, another way to state y values, if the y values are less than or equal to the y value at c for all of the x's in the interval, then f of c is a relative max of the function. Okay? So for instance, if we look at this first relative max we saw up here, this rule is just saying, let's say this is our f of c. If all of the other f of x values, all the other y values are lower than f of c, which in this case they are, then f of c is a relative max. It's a high point, right? And then the same goes for mins. So this says if all the y values are greater than the y value at c for all the x's in the interval, then c is a minimum, a relative minimum. So that's kind of the math terminology for mins and maxes. To actually find them using calculus, we're going from an equation, we're going to use the first derivative test. So, and if you'll notice, this first derivative test is going to sound just like our increasing and decreasing test, but just a little bit added to the end. So to find max and mins, we first identify all of our critical numbers, which we'll call the c in this for a function. And again, the critical numbers are where the derivative equals to 0 or is undefined for any x in the domain of f of x. So we're going to talk about that as we go through our examples. Then we can say that a critical number excuse me, is a relative max if the derivative is positive, less than for the numbers less than that c, and negative for the values greater than c. So what this means is when we look at our number line, and let's say we found a critical number of 0, and we found that it was increasing to the left of 0 and decreasing to the right, then this would be, then we know the function's going up to the left and down to the right, so this would be a max. C is a relative min if, let's say again, I'm making up a critical number of 0, if the derivative is negative for all the values less than c, or the interval to the left, positive for the values of x to the right, then we know our function is decreasing, then increasing, and we know we would have a relative min. Okay, so that's considered the first derivative test we're going to use today. A couple notes here that if a value of x makes the derivative 0 or undefined, but is not part of the domain, it's not a critical number. And again, we'll get to that in some of our examples. We can still use it for the intervals of increasing and decreasing, but it cannot be a relative min or max. Okay, and then this last little point is just a clarification or a reminder that we use the derivative to find x, but we're going to use the original function to find our y values, okay, which again, we'll look at in examples. Okay, so let's get to some of these examples. So first example, find all the relative extrema for this function. So first thing we're going to do is, again, take the derivative. So we get 6x squared minus 6x minus 72. We set that equal to 0, and we solve. First thing we're going to do in solving this is take out our GCF of 6. And then we factor what's left. So we get x minus 4, x plus 3. We solve each, and our critical numbers are 4 and negative 3. So now we need to test these intervals. So we're, again, just like we did on our homework. So for f of negative, for the first interval, let's choose -4. I'm going to plug it in to my factored form here. So I'm going to get 6 times -8 times -1. If I multiplied all those together, I would get a positive number, so it's increasing on that interval. Middle interval, I'm going to choose 0. So I plug it in, and I get 6, -4, and 3. So I'm going to get a negative, so it's decreasing on that interval. For my last interval, I'm going to choose 5, and I plug it in. I get 6, 1, and 8. So I get positive, so it's increasing. So now I can see if my function is increasing on this interval and then decreasing and then increasing, then I can tell at -3, I have a max. At +4, I have a min. So my answer here is I have a relative max at x equals -3, that's where it's occurring, of, so my of represents, okay, if I have a max at -3, what is the maximum value that it hits? What's my y value? So to find out the of for this answer, to find out my y value, I have to plug in -3 into my original equation. Okay, so I'm going to go back to my original equation, and I'm going to find f of -3. And if you plug it in, you'll find that that is 150. So I encourage you guys to plug it in, all right, to just plug in your calculator. So I have a relative max at -3 of 150. I have a relative min at x equals +4, right? Because it was decreasing and then increasing. So that's a relative min at x equals 4 of, again, my of is the actual y value that the function is hitting at 4. So I would again plug in 4 to my original equation. And when I do that, I would get -193. So my final answer for this problem is a max at -3 of 150, a min at 4 of -193. Okay, again, we're eventually going to use this to sketch some graphs of equations, but this is just one step. Okay, let's try another one. So here we have another equation. We're finding the extrema for this equation. So again, first thing we need is our critical points. So we take our derivative, 6 times 2/3 x to the -1/3 minus 2. When I clean this up, 6 and 3 cancel or simplify. So I get 4 over x to the 1/3 minus 2. Now I set that equal to 0 and I solve. 4 over x to the 1/3 equals 2. Now again, I need to solve this equation. So I added 2 to both sides. Now I'm going to multiply both sides by x to the 1/3 by my denominator. Those cancel, and I get 4 equals 2x to the 1/3. I'm going to divide by 2, and I get x to the 1/3 equals 2. So if x to the 1/3 equals 2, I need to find out what actually x equals. So I'm going to cube, or take to the 3rd power, both sides, right? So x to the 1/3 taken to the 3rd power will give me just an x. 2 to the 3rd gives me 8. So I have a critical number at 8. Okay? Now, if you remember though, our critical numbers have to consist of values that make the derivative 0, which is right here, right? This was what made the derivative 0, but it is also values of x that make the derivative undefined. And what that really means is, are there any values that would give us a 0 in the denominator of our derivative? If we look at this as our derivative, you can see that, yes, with this terminology, this term here, x cannot equal 0, right? If x is 0 in this equation, I'll rewrite it here. This is our derivative. If x equals 0, then we have a 0 in the denominator and our function's undefined. So this gives us another critical number of 0. Okay, so now we need to check. We've got 3 intervals now. We need to check for a max or a min. So first, I'm going to plug in a number less than 0. I'm going to go with -1. And I plug that in to my derivative. Third root of -1 is -1. So I end up with -4 minus 2, which gives me a -6. So this interval is decreasing. I choose a number between 0 and 8. Let's say +1. I take the cube root of +1, gives me a 1. So I get 4 minus 2. So I'm increasing between 0 and 8. Choose a number greater than 9. So I mean greater than 8. So I have to choose a number greater than 8. I'm going to go ahead. Well, I'll go ahead and choose. Because I have to take a cube root, I'm going to go ahead and actually choose 27. Because 27 is a perfect cube, right? 3 cubed is 27. So if I can choose any number greater than 8, all right? So I'm going to choose 4 divided by 27 to the 1/3 minus 2. If 27 is positive or negative, that means the whole interval is positive or negative. So I just chose a number there that would make it easy to simplify here. If you had chosen like 9 or 10 or something like that, you could use your calculator. But I just chose 27 so I could do it by hand. So I keep my 4. The cube root of 27 is 3 minus 2. So 4/3 minus 2 is going to give me a negative number. So I'm decreasing. So now I can see if I'm decreasing on this interval, then increasing, then I've got a min at 0. If I'm increasing, then decreasing, I've got a max at 8. So now my final answer is going to be a min at x equals 0 of, I plug in 0 into my original equation. I find f of 0 is going to be 6. So again, here's my original equation. 6 times 0 to the 2/3 minus 2 times 0. So that's going to be 0, right? So I got a min of 0 at x equals 0 of 0. I have a max at x equals 8 of, I'm going to find f of 8. So 6 times 8 to the 2/3 minus 2 times 8. So you can plug in 8 to the 2/3 on your calculator, but it's actually 4. So this term right here becomes 24 minus 16 is 8. So I've got a min at 0 of 0 and a max at 8 of 8. Okay. All right, so now you guys, I know this is kind of a lot. So you guys may, if this is a day where you're in the classroom and you're listening to this, my speed, I might be going too fast. You all may want to listen individually on your own after this and maybe slow it down or stop to catch up. You know, if I'm going too fast, I apologize for that. It's hard to do that when I'm down. Okay, last one. So we're going to find the relative extrema of this problem. So again, first we're going to take the derivative. So derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. So to simplify this, we're going to FOIL these two first. And we get 2x squared plus 4x minus 6x minus 12. So I get 2x squared minus 2x minus 12. And I'm going to distribute this negative for this next part to combine like terms. So I get negative x squared plus 6x minus 9. So my denominator simplified, when I combine like terms here, I get x squared plus 4x minus 21. All over x plus 2 squared. Okay? So now, again, I need to find out what makes the derivative 0. So I set it equal to 0. I multiply by the denominator on both sides to try to solve. And I end up with x squared plus 4x minus 21 equals to 0. To solve that, I factor. And I get x, what's that, plus 7 and x minus 3. So I get negative 7 and 3 are my critical numbers. Now, I also want to look at what makes the derivative 0, which would be negative 2, right? But I'll talk about this more next week in class. But I don't include negative 2 as a critical number because it's not in the domain of my original function. If you look at the original function, it's going to have a hole or an asymptote in negative 2. So it cannot be a max or min if it doesn't exist. So anyway, I'll talk more about that later. But just for now, just know that our intervals are negative 7 and 3. So if I choose values to plug in, say I choose negative 8, and I can plug it into my factored form. Actually, I can plug it into my factored form down here. I don't have to worry about the denominator because the denominator will always be positive because it's squared. Again, I can talk about that more next week. But just know for now, if I plug in my values into that numerator, that'll tell me positive and negative. So if I plug in negative 8 down there, I get a negative 1, negative 11. So I am increasing on that interval. If I choose 0 for my middle interval, I get a 7 and a negative 3. So I'm decreasing. And if I choose, let's say, a 4 for my last interval, I get an 11 and a 1. I get increasing. Okay. So once again, I'm increasing, then decreasing, then increasing. So I have a max at negative 7 of, if you plug in negative 7 into the original function, you get negative 20. So a max at negative 7 of negative 20. And I have a min at 3 of something. I find f of 3 and I get 0. So I have a max at -7 of -20 and a min at 3 of 0. So that's all we're gonna do right now. And I've kind of laid a lot on you guys for a video. But that should give you enough to practice some of this, and then I'll talk more about it in our next class and go over more examples in detail. But I wanted you guys just to get the mechanics of it. So again, it is finding, increasing, and decreasing, just like we've done on our homework, and then using the pattern of increasing and then decreasing to identify a max, and then using the pattern of decreasing and then increasing to identify a min, plugging those values into the original functions to find to find just how low or how high those functions are going at those points. Okay, so I think that's enough for notes today. So for homework, I want you to do on this next page 1 through 7 odds, where you're just identifying the locations, which again means the x values, and the values of, which is the y values. So find the x and y values of all the relative extrema. And again, by relative extrema, we mean relative max and mins. So do that for the odd graphs right here. And then on the equations, I want you to, again, these are polynomials. These should be very straightforward. Find the relative mins and maxes of the polynomials. And go ahead and give all of them a shot. See how you guys do. We'll go over them in class next week. So anyway, hopefully you guys were able to follow this. If not, again, listen to it on your own if you need to go slower, and you can pause and start again if you need to. So anyway, I hope you guys all stay safe and careful, and I will see you guys next week. Thank you.